Hey. All right. Section 2.3, page 121, 1 through 25 odd solutions. I was able to cram the 1 through 9 on here, save us a little time. So on 1, 3, and 5, we are taking a derivative and then plugging in a value. So number 1, we have 1/3 times 2x cubed minus 4. I wouldn't do the product rule on this. I would just distribute the 1/3. And so that'd give you 2/3 x cubed minus 4/3. Then take the derivative using the power rule. So 3 times 2/3 would be 2. And then subtract 1 from the exponent, you have 2x squared. Derivative of negative 4/3 is 0. So we're going to plug in a 0 for that x, and you would get 0. All right, so the next one, f of x, and we have this function here. And this is classic product rule. So f prime of x is the first times the derivative of this second function, so that'd be 4x plus 3, plus the second times the derivative of the first function, that'd be 3x squared minus 3. Now we're going to plug in a 0 for x, so you'd have a 0 here and then a 3 here, plus 5 here, because the others go to 0, and then negative 3 here. So you'd have 0 plus negative 15, which is negative 15. Number 5 got a little bit of trig here, so we have x times cosine of x. So f prime of x, the first x times the derivative of cosine, which is negative sine, plus the second cosine times the derivative of x, which is just 1. All right, so that's going to be x times negative sine x plus cosine x. We're going to plug in a pi over 4 for x. So I'd have pi over 4. Now, sine of pi over 4 is root 2 over 2. Make it negative. Plus the cosine of pi over 4, also root 2 over 2. And so I'm just going to clean this up a little bit. You don't have to get a common denominator. The back of the book might have done that. But I would have negative pi times root 2 over 4 times 2 is 8 plus root 2 over 2. We could multiply this by 4 over 4, and then we'd have a singular fraction, but that's more work than you have to do on my account. Okay, number 7. So we've got x squared plus 2x over x. We're going to rewrite this as x squared over x plus 2x over x, and that will simplify into x plus 2. So this is not, you don't need to use the product rule at all. The derivative of x plus 2 is just 1, because derivative of x is 1. So y prime is equal to 1. And then number 9, we have y is equal to 7 over 3x cubed. I'm going to rewrite that as 7/3 x to the minus 3. Bring that x cubed up a level. And then taking the derivative using the power rule, negative 3 times 7/3 would give you negative 7. Subtract 1 from negative 3. Negative 7x to the negative 4. We're going to rewrite that with a positive exponent. That'd be negative 7 over x to the 4th. All right, let me erase here, and we'll move on to number 11. Okay, number 11. We have y is equal to 3x squared minus 5 over 7. I'm going to rewrite that as 3x squared over 7 minus 5 over 7. So y prime is going to be, all right, so that's going to be 6x over 7, right? Or if you want to do 6/7 x, and then minus 0. Okay? So that's it. 13. Okay, we've got f of x is equal to 3x minus 2 over 2x minus 3. So classic quotient rule. F prime of x is going to be the bottom, 2x minus 3 times the derivative of the top, which is 3, minus the top, 3x minus 2 times the derivative of the bottom, that's 2, all over 2x minus 3 all squared. That is good enough for me. I'm sure the back of the book is going to distribute the 3 and distribute the 2. You don't have to do that. Usually on the test, I ask you to plug in a number there, and then it's easier for me to grade. I just look and see if you got the number right. All right, 15. We got f of x is equal to 3 minus 2x minus x squared over x squared minus 1. Okay, so f prime of x using the quotient rule, hope I got enough space, the bottom, x squared minus 1 times the derivative of the top. Derivative of 3 is 0. That's negative 2 minus 2x. Minus the top, 3 minus 2x minus x squared. Times the derivative of the bottom, that's 2x all over x squared minus 1 all squared. Leave it be. That's good enough for me. Number 17. All right, excuse me. I was just there is quite a bit of simplification you can do on number 15 if you multiply all that out, but it's just not worth it. If you're watching this and your teacher makes you do that, then I will do some videos in the future where we go through and do all that. Okay, so this is just number 17, x plus 1 over x to the 1/2. I would probably, instead of using the quotient rule, because honestly I try to avoid the quotient rule if I can, it's the same as x over x to the 1/2 plus 1 over x to the 1/2. Okay, that's the same thing. X over x to the 1/2 is just x to the 1/2. Remember, you subtract, that's 1 minus 1/2. Subtract the exponents. And then plus x to the minus 1/2. And now I'm going to take the derivative. F prime of x is 1/2 x to the minus 1/2 minus 1/2 x to the minus 3/2. So negative 1/2 minus 2/2 minus 3/2. That's the derivative. Let's clean it up. So that's going to be 1 over 2 times x to the 1/2, which is just root x, minus 1 over 2x to the 3/2. And I'm fine if you write that as x to the 1/2. But that, I think that's probably the easiest way to do that, instead of, I only do quotient rule or product rule if I have to. All right, so number 19, let's see. I'm going to see if I can squeeze it in here. So we've got h of s is equal to s cubed minus 2 all squared. So I'm going to FOIL that out. There is something called the chain rule that I will be teaching you soon, where you can take the derivative of this real fast, but you don't know that yet. So h of s, that'd be s to the 6th, so I'm foiling this, s cubed times x cubed, minus 4s cubed, right? So that's negative 2s cubed plus another negative 2x cubed, 2s cubed, plus 4. So h prime of s is going to be 6s to the 5th minus 12s squared. And then the 4 is 0. So that's all there is to it. I would, again, you could product rule that, but it's probably easier in this case to FOIL. You could do first times derivative of the second plus second times derivative of the first. In this case, that was so straightforward to FOIL it out. That's the way that I did it. But either way, if you simplify down, you will come up with that same answer. Okay. Last few. we've got h of t is equal to t plus 1 over t squared plus 2t plus 2. All right, this is classic quotient rule. All right, bottom t squared plus 2t plus 2 times the derivative of the top, t plus 1. I'm going to go ahead and write it, but you actually don't have to write it, but the derivative is 1. Minus the top, t plus 1 times the derivative of the bottom, 2t plus 2. All over the bottom, t squared plus 2t plus 2, all squared. There you go. Leave it like that. Don't try to simplify it, because usually I'm going to have you take the derivative at a particular point, find the value of the derivative at x equals 1 or 2 or something like that, and you're just going to plug the numbers in. So why take the risk of simplifying it out? Now, if you were taking some sort of multiple choice test, like on the AP test, then you might have to do that in order to match the multiple choice answer. But in this case, that is fine. All right, 23, we have f of x is equal to 3x cubed plus 4x times x minus 5 times x plus 1. All right, what I'm going to do here, I want to get this into two terms so I can use the product rule. So let's FOIL these term 2 and term 3. So that'd be x squared minus 5x plus 1x, so minus 4x minus 5. Now I can write it like this. F of x is equal to 3x cubed plus 4x times x squared minus 4x minus 5. Now we're going to product rule it. First, 3x cubed plus 4x times the derivative of the second, 2x minus 4, plus the second, x squared minus 4x minus 5 times the derivative of the first. 3 times 3 is 9, x squared plus 4. All right, that's good enough for me. I'm on 23. Okay, 25. Let's see, 25. Let's go ahead and give 25, since that one, I usually work number 25 for my students. They ask me to work that one every year because people just don't like, they want a number, they don't want a C. Okay, so let's give it its own whiteboard. So 25, we have f of x equals x squared plus c squared over x squared minus c squared, where c is a constant. So you have to treat c like treat it as a 1. You know, think of it as a 1. Okay, f prime of x, this is going to be quotient rule. The bottom, x squared minus c squared, times the derivative of the top. Well, that's just going to be 2x because the constant just goes away. So the bottom times the derivative of the top. Minus the top, x squared plus c squared, times the derivative of the bottom. Also going to be 2x because that minus c squared, derivative of a constant, is 0. All over x squared minus c squared, the bottom, all squared. All right, that's all it is. Okay, we could, the back of the book might factor out a 2x, but this is perfectly fine. Perfectly fine for me. All right, that does it for this video. I will talk to you on lecture 2.3b.